let's continue just in the
Okay. Well, Kathleen and Molly can use it as well. Okay, so water's flowing into a tank over a 24-hour period. It doesn't say anything about it stopping. It's always flowing over that 24-hour period. The amount of water is measured at various times, and we have results in the table. W of T is in gallons, and T is in hours. And there are 150 gallons of water in the tank at time equals 0. That may or may not be important to us later, but that is some initial condition. Now, is this a continuous function? Does it say anything about it stopping and starting?
It is. No.
No, so we could say that this is a continuous function. That may be helpful later on, but it is a continuous function. Now, it's saying to use the data from the table to find W of 8, and using appropriate units explain the meaning. So what is W of 8?
221 gallons.
Okay, so you told me it's gallons, but what really does all that mean? W of 8 equals 221 gallons. What does that mean?
W8 is 221 gallons in 8 hours.
Okay, at time equals 8 hours, there are 221 gallons of water in the tank. If it asks you to explain the meaning, you need to be sure that you talk about at what time there are that many gallons. At 8 hours, there are 221 gallons of water in the tank. Okay, now ask us to use the data from the table to find this. What does this mean? W to the negative 1. Inverse.
So it's going to be 12.
Okay, so what does that mean to us? What you said that.
It would be 12 hours. It's 2:57 and back to T hours.
Okay, inverse functions, you go backwards. So there are 257 gallons at 12 hours. Right there. Okay, you see now how to figure that?
I do. I was
Just didn't take time to examine the table. Okay, you all have your table still showing, hopefully so. It tells us to use data from the table to find an approximation for W prime of 15 and show the computation using appropriate units. Explain your answer. All right, what does W prime of 15 mean? What does that prime mean? Derivative. Okay, so how could we approximate the derivative, which is a rate of change? How would you approximate it at time equal 15? Do we have time equal 15 in our table?
No.
Are we close to it anywhere?
find the average.
Yes, 16.
Okay, we can find, now it asks you to show what you used, so it's probably best, this way they know what you're talking about. If you use W of 16 minus W of 12, because that over 16 minus 12. This step's probably not absolutely necessary, but if were you to pick up the wrong number and you had this, you could still get some credit because this shows you knew what you were supposed to do. You just picked up a wrong number from the table. But when it asks you to show the computations, you need to show at least somewhere your 16 minus 12 and either directly the numbers from the table, but it's not a bad idea to put this first. Just to show you knew what you were supposed to do, even though you read the table wrong. 294 minus 257. Now that I've said 16 minus 12 here, I can just say 4. You don't want to just say 4. You don't want to go just to the second step. You need to show the 16 minus 12 somewhere. Okay, and if we subtract 5/37, and you don't have to change that to a decimal approximation. This could or could not be calculator active. If it's not, don't change it. And what does this stand for?
Right.
The WT.
Okay, W prime of t, so it's the rate. What's the rate? The rate of what?
Rate of the water goes into,
The rate at which water
is flowing into the tank.
flowing into the tank when?
Between 12 and 12.
Around 15
At t equals 15.
T.
Now, did we miss anything? What's the rate of what?
Rate of,
What would be our units for the rate?
hours.
Gallons per hour. Okay, so you need to be sure you use your units and explain the meaning and show the computation. Okay, number D says to use data from the table to find the average rate of change of WT over the time period from 4 to 20 hours and show the computations that lead to your answer. Any ideas? William?
Yes, just use the 20 minus.
Same thing we just did.
Minus W4.
W of 20 minus W of 4 over 20 minus 4. And so that's 327 minus 184 over 6.
8.
4 from 7 is 3. 8 from 12 is
43.
4.
Maybe over 16, that's all.
1.
Yeah, it's over
One-
16.
Oh,
So-
thank you, 16. See, here again, so see, if you do something like that, but they can come back and see this, you can still get some of your credit, thank you.
For C, school.
Okay, and is it 143
Yes, 143.
over 16? And you probably just leave it like that. And this still, it doesn't say, but go ahead and put gallons per hour. Even though it didn't ask, it's always a good idea to go ahead and put that down. Put your rate,
Should we
your
explain the
units.
rate at which-
You can, but that's just the average rate from 4 to, the average rate at which water's flowing into the tank from 4 to 20 hours. But since it didn't specifically ask, be sure you show your computations. Don't just have an answer. All right, let's look at, hopefully it's on here. Okay, good.
Does the calculus test usually like a question is like with 6 little questions?
It probably won't have this many, but it could combine into two, you could have 2 of these into one part. Whoever made this up looked over several different tests and picked out types of questions that you could see. You may or may not see all of these questions on one problem, but you could, or different parts of it, so. Okay, is from 0 to 24 hours, thinking about your table, you may have to look back at it. Is there a time when the tank contains 265 gallons of water?
Yes.
How do you know?
Because between
12 and 16.
12 hours and 16 hours, the value of WT.
It's a continuous function and
Okay.
constantly increasing. So from 12 and from the interval 12 hours and 16 hours. there
Okay.
is a-
Can you think of a theorem that we've talked about that guarantees that?
Within values. No.
WT is a continuous function.
Oh, the sandwich one. That's correct.
All right, so it's probably a good thing we talked about this. WT is a continuous function, we need to state that. because, and I'm just going to abbreviate, because W of 12, which is equal to 267, or 257, is less than 265, which is less than 294, which is W of 16. The intermediate value theorem, the IVT, guarantees there is a time when the tank has 265 gallons of water.
What's IVT?
Intermediate value theorem. Okay, and you can use IVT. They'll recognize what IVT is. They would expect to see intermediate value theorem referenced on this question. But if you want to just, they would know IVT is the intermediate value theorem, MVT is the mean value theorem. But the intermediate value theorem, remember we even did some of that last year in pre-cal. You can't get from here to here on a continuous function without going through every point in between. So if you've established, and you all actually said it, we just have to also quote the theorem or reference that theorem. But your reasoning used the intermediate value theorem. Okay. Tells us a model for the amount of water in the tank is given by, and then they tell us, where A of T is measured in gallons, and again, T is measured in hours. Now we want to find A prime of 15. So what do I need to do?
Find the derivative of A.
Differentiate.
Find A prime. And this is one you can do. A prime of T is going to be equal to 1 over 225. Just leave that out front. Of a negative 3T squared plus 60T plus 1800. Now, if this were actually a question, you would get a point, I'm sure, just for finding the proper derivative. And these numbers are kind of big, so my guess is if you had something with numbers this big, if they ask you to find A prime at 3, they might not expect you to plug it in by hand. And you could plug in 15 by hand, but now you just plug in 15. For time's sake, if you will, believe me, it's 9 gallons per hour. I mean, that's not such a big number, you couldn't figure it out. Make sense, Oscar?
Yes.
Okay. Now G says to use that same model, so that means we're not going back to the table. Use the model given in part F to find the average rate of change over the time period from 4 to 20 hours.
So it's just still the same as
Yeah, it should still be the same answer.
Well, may not be exactly the same because now we're not looking at numbers from a table. We're looking at numbers that we calculate from a formula. So again, show your calculations. You would have A of 20 instead of W of 20 minus A of 4 over 20 minus 4. Now in a case like this, if you can use your calculator, I would probably go ahead and put A in Y1. And then your calculator makes it easy. Then you can just plug in here and here, show this, but if you have A into Y1, then it just is a little bit quicker for your calculations. And if you can use your calculator and it makes it easier to do something, use your calculator. And if you do that, you'll probably get a decimal approximation. All right, so here, just use your calculator and you can get an approximation. And I think if we went back and looked at the other one where we used the table values, we had 143 divided by 16, and that was 8.938 gallons per hour, if you got the decimal approximation. So they're close, but they weren't exactly the same. Okay? So you have in your packet 4 more sets of these kinds of problems to do for practice. They're not difficult,
That's good.
but you need to do them for practice so that if you see them on the AP exam, hopefully it'll ring a bell. You can also see questions similar to this on your next test.
I see